Imagine a network of tiny sensors scattered across a vast farm, monitoring everything from soil moisture to temperature. However, these tiny sentinels face a significant challenge: limited power. LEACH offers an ingenious solution to prolong the life of these crucial networks. From agriculture to healthcare, LEACH plays a crucial role in enabling these networks to perform their tasks efficiently. LEACH stands for Low Energy Adaptive Clustering Hierarchy. This name itself hints at the protocol's core functionality. Low energy emphasizes its primary goal: minimizing power consumption. Adaptive indicates its ability to adjust to changing network conditions. Clustering hierarchy describes the organizational structure it employs to achieve energy efficiency. LEACH is a hierarchical routing protocol specifically designed for wireless sensor networks. It aims to extend the network's lifetime by minimizing the energy expended by individual sensor nodes. This is achieved through a clever combination of localized data aggregation and rotation of cluster head responsibilities. Sensor nodes within a cluster transmit their data to the cluster head, which then aggregates and compresses the data before transmitting it to the base station. This distributed approach to energy management is key to LEACH's effectiveness in prolonging the lifespan of wireless sensor networks. Clustering is the cornerstone of LEACH's energy-saving strategy. It involves grouping sensor nodes into local clusters, each headed by a designated cluster head. This organization simplifies data transmission and reduces overall energy consumption. Without clustering, each sensor would need to transmit its data directly to a distant base station. This requires significant energy, especially for sensors farther away. Clustering solves this problem by creating local data aggregation points. Within each cluster, the cluster head acts as a central collection point. Sensor nodes within the cluster transmit their data to the cluster head, which then processes and compresses the information. This hierarchical approach significantly reduces the number of long-distance transmissions. By sending data to a nearby cluster head instead of a distant base station, individual sensor nodes conserve valuable energy. The cluster head plays a crucial role in LEACH. It acts as a local coordinator, responsible for data aggregation and transmission to the base station. This centralized data handling reduces the overall energy consumption. Each sensor node transmits its readings to the cluster head. The cluster head then performs data aggregation and compression. Finally, the compressed data is sent to the base station. A key innovation of LEACH is the rotation of cluster heads. This dynamic approach ensures that the energy-intensive task of data aggregation and transmission is distributed among all sensor nodes, preventing any single node from being overburdened. If a single node were to remain as the cluster head indefinitely, its battery would deplete much faster than other nodes in the network. LEACH addresses this issue by periodically rotating the cluster head role. Each sensor node has a probability of becoming the cluster head in each round. This probability is calculated based on factors such as remaining energy and previous cluster head assignments. The rotation ensures that the energy consumption is distributed more evenly across the network. By distributing the energy burden, LEACH significantly extends the overall network lifetime. This adaptive nature is what makes LEACH so effective in prolonging the life of wireless sensor networks. LEACH's energy-efficient approach has found numerous applications in various fields. From monitoring environmental conditions in smart farming to tracking patient health and healthcare, LEACH plays a vital role in extending the lifespan of wireless sensor networks. In smart farming, LEACH enables efficient monitoring of vast agricultural lands. Sensors deployed across the field collect data on soil moisture, temperature, and other critical parameters. LEACH's clustering mechanism allows these sensors to operate for extended periods, providing valuable insights for optimized irrigation and crop management. In healthcare, LEACH is used in body area networks, also known as bands. These networks consist of wearable sensors that monitor patients' vital signs. LEACH's energy efficiency is crucial in these applications, as it prolongs the battery life of the sensors, reducing the need for frequent replacements and improving patient comfort. Environmental monitoring also benefits from LEACH, enabling sensors to operate for extended periods in challenging environments, providing valuable data for environmental research and management. LEACH has revolutionized the field of wireless sensor networks by addressing the critical challenge of energy efficiency. Its innovative clustering and cluster head rotation mechanism significantly extends the operational lifespan of these networks, enabling wider deployment and more sustainable monitoring solutions. By organizing sensor nodes into clusters and dynamically rotating the role of the cluster head, LEACH optimizes energy consumption and prolongs the network's lifetime. This approach has proven to be highly effective in various applications, from environmental monitoring to healthcare. LEACH's impact extends beyond simply extending battery life. It enables the deployment of wireless sensor networks in remote and challenging environments where frequent battery replacements are impractical or impossible. This opens up new possibilities for monitoring and data collection in diverse fields. Researchers are constantly refining the protocol and exploring new ways to optimize its performance. LEACH's enduring contribution to wireless sensor networks ensures its continued relevance and importance in the future of interconnected systems.